All right. So the plan for today is to spend, I think, about 20 minutes, okay, working through an example where we're going to reinforce the material from last time, okay, which was all about 2D plotting, okay, and hopefully that was helpful to you. Um, yeah, it's particularly line specs and line properties and that kind of stuff. I know that type of thing. It doesn't matter which software program you're using. When you're learning all that new syntax, that can be kind of intimidating sometimes. I just as an example, I use quite a bit of R, and there's a package or library that I use in there called ggplot. It's got the grammar of graphics. It's got its own syntax. You end up with beautiful, beautiful plots, but it's definitely a learning curve. So if you're struggling with this a little bit, that's why I want to use this time to to just allow us some time to ask questions based on last time, and we'll introduce some new ways to refine your figures that are kind of, I think, will get you all the way to where you need to go for future courses in creating figures. We're going to talk about what to do with the figures. And just a heads up on that. Do not screenshot your figures and put them in documents. Okay. Like there are ways to put them in documents that make them look kind of nice. All right. Screenshot emails all day long, screenshot message boards all day long. But when it comes to actually putting these things in documents, there's a better way to do it. It's really simple. But that's where I want to get today. And we'll do a little bit of 3D plotting and just kind of wrap it up. So as we're going, okay, make sure that you stop me and ask questions as we're doing this. Okay. So right now, download, there's some code on Canvas. Okay. It's a starter code. There's two things. So um, there's a cheat sheet. Okay. That has, a list of the functions that we're going over, the different types of processes there. Are these helpful for you? Have you found these cheat sheets to be helpful? Is this good? Okay.
Yeah, I find
Um,
it really helpful.
okay. Good. Who was that? That was Rory.
Yeah.
Okay, good. My goal here with those cheat sheets is that when you're using MATLAB in the future, in future classes, just download these things. Okay, like have a folder of MATLAB cheat sheets so that you can just go to them, click on it. Oh man, I forgot how to use this type of indexing, or I forgot how to use fprintf. Right, so just go to that. So you can reference it in the class. So yeah, like I said earlier, I'll take feedback on any of this. I want you to have these tools and resources moving on to the next piece, since this is a supporting course. Um, so there's a cheat sheet there, okay, that is gonna be specifically for this type of refinement. We're gonna use a num to string command, and then 3D plotting. Okay, so you're gonna find 3D plotting is just kind of this, whatever. But we are going to do it because you've got some problems that use it, and we'll introduce some other plotting as we move through. But today is going to be our last day where we're just dealing with visualization. Okay, we'll just be refining that as we go through the numerical methods problems in the future. But right now, download it's called Triangle Coordinates in 3D Starter Code. Okay, so that's on Canvas. That's the second file that's posted there. And what this is so I got a chat here, is lesson 7. Yes, lesson 7 will be covered on the WPA. So so pay attention to what we've got here. It's going to be functions and plotting. So if you got those functions down, then and plotting down, you should be good. Okay. Um, and so today, after we finish this up, we'll do our normal office hours or coaching, type session that we've got. So pull up in this triangle coordinates. Oh man, I misspelled that. Coordinates. Coordinates. There we go. All right. All right. Triangle coordinates in 3D starter code. Okay. And so the header is just we're gonna take this script and we're gonna show or display a triangle in 2D and 3D when given Cartesian coordinates of the triangle vertices. Okay, so that's our plan. And so what I've done here is I've got the point 1, point 2, and point 3 that we dealt with earlier in the geometry of the triangle function, and I've added a a z coordinate to each of these. Okay, so we got our three-dimensional Cartesian coordinates. Okay, and then there's two spaces down here. So our pseudocode, looks like we've just got to plot a 2D and we got to add a 3D plot. And we're going to add that not as a separate figure, like you did on the last homework in the butterfly plots, but instead we're going to add it as a panel. Okay, we're going to talk about this way to incorporate multiple graphs and multiple panels within a figure. Okay, so that's where we're headed today. And so let's just, what I want you to do is only using the X and Y coordinates. Okay, at point 1, point 2, and point 3. Okay, take a little time, take a couple minutes. Okay, and use the plot command. Okay, to just make a triangle, and then add some formatting to it. Okay, so your choice on any type of line style, and make sure you put a marker on it as well. Okay, any marker, any type of line style, and then increase the line width. Okay, do the instructions make sense? Give me a thumbs up if you've got the instructions. Okay, so the goal is to just make a triangle, make it look like a triangle. All right, how are we doing here? Give me a thumbs up when you've got the triangle. All right, has anyone gotten a triangle yet? What's another symbol we can use? Give me a, if you're on the screen, give me a thumbs down, or give me the party emoji if you're just struggling to get that triangle. Okay. All right. I only see one party emoji. Does that mean everyone else has got it? Oh, there's another party. Party. It's a party, guys. Okay. All right. It's a pity party. All right, let's figure this out. All right. So take a look at my screen again, and let's make sure that we understand the 2D plot command then, okay? So, so when using plot, okay, it's always going to be the plot format XY. Then we add our line specs, we add our line properties and so forth. And so when putting in our X and our Y, okay, we want to put in a matrix for our X and a matrix for our Y. Okay. So how many people did this? Give me a thumbs up if you did this. Did plot X1, X2, X3 as a matrix, okay? And then Y1, Y2, Y3. Okay. I got one person that did that. Right. Well, I want to run it this way. So first off, can you see why this would be the syntax? You know, if we've got an X, a set of X's and a set of Y's of coordinates. So X1 versus Y1, X2 versus Y2, X3 versus Y3. Okay. I'm going to run this and we're going to see what this looks like. And then, all right. So first off, you can see that we don't have a triangle. Okay. Why don't we have a triangle? I mean, what's missing? I mean, this is I just want to be really simple about it. Like what's actually missing here?
Missing one of the sides.
Yeah, we're just missing one of the sides. Okay. And so, so I want to keep this figure in mind. Okay. But as we're looking here, we have an X1 versus a Y1. Okay. And then that means it's 4 and then 4, X equals 4, Y equals 1. Okay. So it means that's this point right here. Okay. 4, 1. And then our next point is going to be 2, -3. So it's this point right here. So you can see what it's done is we've started at this point and we've drawn a line to the next point, then drawn a line to the third point. Okay, and the third point is 0, 4. So you can see we're 0. Yeah, we're 0 on the horizontal axis and then 4 on the vertical axis. Okay, give me a thumbs up if you're good with that. At least understanding the syntax that I have here. Okay, give me a party if you're way confused on this. Okay, I don't see any parties, so I'm gonna say that this is okay now. Okay, so we're going point 1, point 2, and point 3. So then what we need to do is we need to close that triangle, or from your perspective, we're gonna close that triangle from point 3 to point 1. Okay, so that means down here, let's take a look. What can we do to this to close our triangle? If we've gone from point 1 to point 2 to point 3, okay, what does it look like down here to close that triangle? Does anyone have anything to offer here?
Don't we just return to point 1?
Yeah, that's exactly right. We're going to return to point 1. And what's the syntax look like to do that? Was that you, Masad?
Yeah, wouldn't we just put x4 is equal to x4 and y4 are equal to the same coordinates as point 1?
Yeah, so the fourth element, okay, is going to be x1, okay, and the fourth element is going to be y1. So yeah, you're on the right path, but we don't have an x4. We want to go back to point 1, like you said earlier. So we're going to start at 1, go to 2, go to 3, and go to 4. Does that make sense? So run it and see what you get. So we've now connected our triangle. Okay, so keep this in mind, is that when we put matrices, okay, which is what we're doing pretty much anytime we're plotting, okay, it's rare that we'll just do single points, but it's going to be a matrix versus a matrix, okay, and that matrix needs to include all of the x's, all of the y's, and then when we do our three-dimensional plotting, all of the z's, okay, and then it's going to go from the first point to the second point to the third point. So, I mean, the next thing we need to do, okay, the next part of the instructions, we're to add some line specs and some line properties. Okay, so do that. Do whatever you'd like to do here. Okay. I'll paste in what I was going to do. I was just generic. I did circles. I made it blue. I did a line width of 3. Actually, you know what? I'm going to take out the blue. Let's do something different. Let's do mentioned this command last time, but we didn't do anything with it. If we want to do an RGB, then we can do something, putting our own numbers in here. I have no idea what color this is going to be. Let's find out. Oh, didn't work. What didn't it like? Oh, between 0 and 1. Okay, needed a triplet. 0.5, 0.89, 0.1. Okay, there we go. I got a lime green out of putting a 0.5, 0.89, and 0.1 in there. Okay, so our RGB, if I'm not mistaken, it goes from 0 to, is that 256? And then it's scaled in this with an R, G, and B combinations. Okay, and there's lots of ways to figure out your RGBs. I use this quite a bit when I'm matching colors. If I want to use the DU colors, I can download the RGB of DU and that kind of thing. Okay. So, all right, has everybody made it this far where you've done some specifications? Give me a thumbs up. Okay, looking good. All right, so now that we made it this far, okay, we've made a triangle, and let's start refining this a bit. Okay, so first off, whenever I was examining this and trying to figure out, okay, which one's my coordinate 1, which one's my coordinate 2, I mean, I needed to, come to these axes, and then it can be a little bit difficult, right? We've got whole numbers here. So I want to give you a command that really I recommend using with every single plot you make, okay? And it's called grid on. Okay, so type that in or run it again. And then this is giving us some construction lines to be able to actually determine where your points are on a plot. Okay, and so you just get a better idea of how these things are laid out. You can troubleshoot your plots a lot easier. So the next piece is, what do you see here in terms of, if you were going to draw this triangle, if you were going to draw this triangle, like, is this the end on a piece of grid paper, is this the shape that you would get? Do you see something a little off? Yes, that's what I'm asking for. What do you see that needs a little bit of help here?
The scales aren't even.
Yeah, that's exactly right. The scales aren't even. So you can see on the horizontal axis, we're going 0 to 4, okay? And so each of those grid chunks is in a half, it's doing half of our increment. So let's say it's in meters, it's giving us a ½ meter increment. But on our vertical scale, you can say this scale is each square is giving us a meter, okay? So it's our aspect ratios on our Y and our Z. We've got a 2-to-1 aspect ratio that's occurred, okay? So again, when you have data that are the same units and you're plotting those data on the X and the Y, it's just much better if we're looking at this and we can actually see, in this case, the geometry, the shape of it, okay? I mean, yes, it's a triangle, that's nice, but it's not actually the shape that we're looking for. Okay, so there is a series of properties called axis properties. And the one you want here is what's called axis equal. Okay, and that's going to change the aspect ratios to be 1-to-1 on these axes. So I'm going to run this again. This is our actual shape, okay, of the triangle based on the coordinates that we have. And you can see that it's if we expand out or in, it's always going to keep those axes. It's always going to keep those aspect ratios the same. And it's giving us, in this case, 1 unit per grid. Okay, and that's something that becomes obvious when you put the grid on there. So that's why, gosh, I recommend just putting a grid on all the time. Okay, so you're not frustrated here. There are different axis commands that you can use. You can just type in help axis, or I'm sorry, doc axis, or up in the documentation, type in axis, and you can find more of those. Okay. All right. So our next question is, if you were going to present this figure, then and you wanted to control the limits here, and let's say, I only want to show, let's go from let's say -1 to 5 on the x-axis. Let's program that into a nice intuitive command called xlim. And in the xlim, we're setting the minimum and maximum limits. Okay. You can look at our cheat sheet here too. Xlim is xmin, xmax. Okay. And we're going to set our minimum, we said, to -2, and we'll set our maximum to +5. Okay. So run this, and then we have now zoomed in, okay? But we've got a problem now on our Y, okay? So let's figure out what we want to do there. Let's go -4 to +5. Let's see what happens there for our Y limb. There we go. All right, so now we've made a rectangle out of it. We've created our 1-to-1 aspect ratio, okay? And we've got our triangle, all right? And we've got everything that we need here. So you can adjust all this. And the point is that you've got a lot of control, okay, with some nice, just basic commands to make your figures look however they want, okay? So get used to using these. Get used to using these so that you can just be a brute force, that you can control the figures in whatever you need to make it look professional. Okay. Now, I want to show you a little bit about refining some of our labels. Okay, and so one of the things that we can do here is that let's put on an X label. Okay, and with the X label that we introduced last time, let's just say we want to do, we want to say that there's an X1 and an X2 and an X3 coordinates. So oftentimes we'll write that as an X and then a subscript 1. Okay, that's how we will often write these coordinates, just when we're writing them. Of course, when we have syntax, we can't make a subscript in this type of editor. But for our X label, if we do something like an X_1, comma X_2, then X_3, type those in, and then let's run that. Okay. Now notice that what we have here is that when we do an underscore, when we make an underscore, it's going to give you the subscript. Okay, it's going to give it to you as a subscript as if you'd write it. And so this type of notation that we're using is called TeX notation. And so when I say TeX notation, it's actually TEX, TeX. And I know that sounds kind of silly. We may have to go to Google to get this. But let's type in MATLAB TeX, and it's actually called TeX markup script. Here we go. All right, and this is where you've got special characters, subscripts, superscripts. You have math functions that you can use, and Greek characters. Okay, now we end up with lots of Greek variables that we use in our classes. You can see here's how we do our subscript, our superscript. You can do a bold font, italics, just lots and lots and lots of options. Okay, so you have lots of options to make your figures or anything in your text look really good. Okay, and I encourage you to use these. TeX is this has been around since the 70s, I think. And so don't call it TeX, it's TeX. And then there's another way of typesetting documents called LaTeX, or if you want to be really pretentious with it, you call it LaTeX, and it's spelled LaTeX. And it's a way of kind of coding your documents, okay? And in engineering, we use that quite a bit. You've seen some of those documents here. Becca has helped me create a couple of these, okay? But I want you to just, whenever you're using MATLAB and you need to use a Greek letter, then just go use it, okay? So we can type in something like theta. And then when we run our code, it should toss a theta in here, okay? And we can do things like let's see if I get this right, a boldface theta, okay, with these curly braces around it. And then this should give us, no, that doesn't look very bold-faced to me, but that's how you type it in for boldface. Okay, so you have lots and lots and lots of options. Okay, so explore those, make your figures look good. So we're in the refinement mode of our figures. Okay, any questions about this? Give me a thumbs up if you've seen TeX formatting, TeX or LaTeX. If that's something you've encountered. Okay, I recommend using it. Okay, it's great. And one of the great things about it is compared to Microsoft Word, for example, LaTeX, you have complete control over the way your equations look. Okay, and you can make your equations look however you want, and it'll be that way every single time. So that's really the beauty of it. All right, so the next thing I want to do is I want you to add a text annotation for the coordinate of 0.2, okay, that shows that you have x1, okay, use this text notation, x1 is equal to, what do we have? X1 is equal to 4, y1 is equal to 1. Okay, so do you remember the text command? We did text, and in using the text command, okay, you can see that you give it an x coordinate for its location, a y coordinates for its location. And this is of the text that you're annotating the figure with. And then the third argument is the text that you're actually putting in there. Okay, so let's see, I want to put it at x1, x2. No, we're doing 0.2, aren't we? x2 and then y2, those are my 2 points. Okay. And then I'm going to add x1 is equal to, let's see here, it is 2, -3. So x1 is equal to 2, and then y2 is equal to -3. Let's get that right there. All right, so we just added a character string. When we pull this up, okay, we see that we get here the x2 is equal to 2, y2 is equal to -3. That's at our location. All right, and of course we can refine this a little bit. If I want to move it down a little bit, well, I'm going to move it down by half a unit, just so it's not covering up my point that's there. Right now, here's a question for you. Okay, I've put in x2 is equal to 2, y2 is equal to -3. Well, what happens when I go and I change y2 is, or let's do x2 is equal to 1. And I run it. Now I've got the wrong label here. So it would be really handy for us if we could accommodate for this so that if I change my x2 value to 1, that it doesn't print out a 2. Okay, does that make sense? So that way you can just automate this for what you need to do. And so to get there, we need to talk a little bit about character arrays. Okay, and so what I want you to see here is that I'm just going to copy and paste these single quotes, and I'm going to put it in the command window. And this is going to assign it to ANS, right? Now come down here and look, we have ANS is a character array, right? So if I size this character array, the size ANS, it's giving me a 1/13. Okay, so it's one row, it's a row matrix, okay, of characters. It's not numeric anymore, but it is a matrix. And what that means is that we can treat this type of command as something that we can take apart and put together just like any type of matrix, because a matrix is a storage container. Okay, that's all that's happening here. So if I do ANS and I reference the third character here, then I should get, oh, that didn't work, did it? Oh, I need to do 1, 3. There we go. That didn't work either.
When you called size of ANS, it rewrote ANS.
Oh, it sure did, didn't it? Okay, thanks. Appreciate that, Nick. There we go. ANS 3. There we go. It's giving me a 2, right? And it's giving me a 2 because my third character within this is a 2. All right, does that make sense? Give me a thumbs up if that makes sense. Okay, great. So I want to change the formatting here a little bit. Okay. So with this array, remember when we worked with numeric arrays, we put square brackets around them. Okay. So if you put square brackets around this, we can now treat this just like an array and we can add things to it. So one of the things I could add, and I'll do it up in the script, okay, is going to be, I'll put the square brackets on, and then I want to add to it on the front end, okay, something that just says .2, colon, and then I'll close it. So we now have a character array that's .2 colon, and a character array that's the x2, y2 is equal to -3. Okay, so if we run this, then we've just tacked on that .2 on the front end. Okay, makes sense? So that means that if we want our 2 to update, okay, each time, then how can we turn our number 2 into a character so that we can put it in this array? So in other words, right, I want to isolate that 2. Okay, I'm going to close off this array, and I'm going to close off this array by putting the single quote there. All right, but now if I run this, it's gonna bark at me. Well, I guess it didn't. Oh, interesting. I thought it was gonna break. But you can see that x2 doesn't have a value here. Okay, for some reason it allowed me to keep a 2 in there, and I honestly don't know why. But it definitely didn't turn that 2 into a character. But what we can do is a command called num2str, num to string. And with that command now embedded, all right, we have our x2 back here. So that means that we can go and we can change x2 to anything we want now. Okay, we can change x2 to 0 and run it. And now you can see x2, whoops, I've got a problem here. I still have my 2 there. So I need to update this to be my x2 variable. Okay, does that make sense? Give me a thumbs up if you see what I did there. Okay, because I want this to be updating as we go. And now, there we go. It should have x2 is equal to 0, y2 is equal to -3. Okay. This is a command that I think I use it all the time, to be honest with you, num to string, okay, because we're working in numerics, okay, and when we're displaying anything, okay, we're displaying it as a character string, character array, and then this allows you to have that type of control. So you can use this in any of these display commands that we've worked with, okay, so meaning the text command, the DISP, X label, Y label, title, okay, you can have these pieces where you've got a numeric value that's updating, okay, in any of these strings, okay. And so I hope you can see, even using this DISP that we've used before for our outputs, okay, if you can make that a dynamic output, that gives you a lot more control in how you output information from your scripts. Okay. All right. A thumbs up or a party, depending on where you are on this. Okay. Get a little bit of party. All right. Good. Let's make sure you got this wrapped up. We'll be using this in the future. Okay. So you're going to get a lot of practice, okay, for how to use this. All right. So then the last thing that we want to do, let's move on to adding that 3-dimensional plot. Okay. So we've got our 2-dimensional plot here. Okay. Let's add the 3-dimensional plot. And like I said, I want to add a 3-dimensional plot to be a panel to the right. Okay. And the way to do that is by using, let's go to our cheat sheet and looking at multiple plots in one figure. And this is the subplot command. Okay. So there are multiple subplots, okay, within a figure. And so you're going to divide, so picture a grid or picture a matrix, actually. This is the matrix laboratory. So let's think in terms of matrices. We've got an M by N matrix, okay, rows and columns. And so the one that's given here is that we've got 3 rows, okay, for each of these plots, and then 2 columns. And so you would do a 3 and a 2. All right, and then the subplots are numbered with increasing numbers, and they go from left to right. So this would be 1, and then 2, 3, 4, 5, and 6. And so you're going to place this subplot command above your plotting. Okay, so let's go back to our code, and let's go through a simple example. If we want this to be on the left, and then we want a 3-dimensional figure to be on the right, then we're going to do a subplot of 1, 2, meaning there's 1 row, 2 columns, and we're going to place this underneath our figure call. Okay, we're going to subplot 1, 2, and then because we want this plot to be on the left-hand side, it's going to be our first plot. So let's just add that. We haven't added any 3-dimensional, our second plot at all. Let's just run this and see what we got. So if I would spell it correctly, then it should give us a 2-panel window, and it's placed the plot that we've already created in the left panel, and then we haven't defined what can go here in the right panel. Okay, now we're going to use this, we're going to use the plot command to put something in this right panel, but really the options are endless. Okay, you can put pictures there, you can put text there, you can put lots of things that'll go in these other panels. Okay, but we want to put a 3-dimensional plot. So that means that we're still in the same active figure. We're going to do subplot 2, 1, and this is going to be our second plot. So let's see what happens when I run it. Oh, I got the wrong one. It should be 1, 2. There we go. All right. So now it's just giving us a blank figure, okay, with no formatting at all. But let's put in a 3-dimensional plot. Okay, and the 3-dimensional plot is going to be plot 3, okay, and it has the same format of X, Y, and Z. X, Y, Z is our format, so we're going to put a vector, 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 or row matrix, row matrix, row matrix. And remember, we have to close off that triangle. Okay, so that's going to look like okay, a series of X's, a series of Y's, and a series of Z's. Okay, you can run that. And then again, we're getting this, it's a plot, and that's great that we've got a plot, but man, that is hard to discern anything that's there, what those points are, where they're located. And so even after we put on our formatting, let's just say we're going to do a blue line with circles, and then let's do our line width so we can see this a little better at 3 again. All right, that's better, but it's still hard to see what this is. Toss that grid on and our axis equal, and this should start looking a little better. Okay, that's great. So now we've actually got the triangle that we need. In these 3-dimensional plots, okay, you have an opportunity to rotate this around, to glance at it from lots of angles. One of the things that whenever I plot these, I don't know which axis is which. I always have to remind myself which one is which. And so this is where your xlabel command comes in handy. Each of your labels, you just put X label, Y label, and Z label, or X axis rather. Y axis, Z axis. Okay, and now we know that we have our Y axis and our X axis. Okay, so hopefully if we rotate so we only see our X axis and Y axis, these two triangles should be the same. Okay, so just get some practice doing that. There's additional commands where you can look at the perspective in different ways. Okay, with this, and that moves, I've mentioned before, it's beyond the scope of this class, moving into the object-oriented programming, looking at what to do with this figure object or with this plot object. Okay, but the main things I want you to take away from this are we now have a figure. Okay, the figure has 2 panels, a left panel and a right panel. We did that using the subplot command, okay? And just a little bit of practice using the three-dimensional plotting, additional annotations using this tech markup language. And then the last thing before we finish up is, what do you do with these things? Okay, you're creating this beautiful document, okay, and in this document that you're going to turn in for thermodynamics or fields or one of those classes, you're writing along, and what I don't want you to do is to do your screenshot. Okay, I love screenshots. They really are wonderful. Okay, that's really not a pretty figure. And screenshots are hard to control. They're often grainy and so forth. But what you do want to do is just kind of use this edit. Where are we? Copy figure. And then paste it. And you can see that is just a much better looking figure than our ugly screenshot here for turning something into your professors or a thesis or anything that needs to be a professional document. And you have the tools now. You've actually got quite a bit of tools on visualization to be able to make your figures look really nice. Okay, bolding, italics, subscripts, superscripts. You can put math in there with the tech markup, and that's something that I want you to have that for when you need to create good looking figures. I mean, you can really do some good stuff in MATLAB. Okay, so this is going to end this focus on visualization. We'll be adding more things as we move along within the class. All right, so we just got a couple minutes left. What questions?
Just a
what
quick
questions do you
question.
have?
Yeah, so instead of putting the matrix inside of the plot function, can you make a function x is equal to a matrix, y is equal to a matrix, and then put x and y as the plot coordinates? Is that bad practice at all?
No, it's not bad practice at all. So I mean, just matrix, okay, outside of the function, and then toss it in there. That's a completely legitimate way to go. Okay, and I mean, there's no good or bad there. Okay, just make sure that it's clear with whoever. I mean, this is always the case, right? Coding is communication. Make sure it's clear what you're doing, to the person who's going to read your code after you write it. It's a good question, Musad.
Thank you.
Can you go back to your code for the 3D plot real quick?
Yeah.
Thank you.
Yeah, you're welcome. And kind of, so what Musad was saying here, just for clarification, is could we just define a big X? Okay. Like an X matrix, and then put X matrix right here. And of course, the answer is yes. All right. Any other questions before we wrap this up? Okay.
I just had one quick comment.
Yeah.
If y'all are ever planning on taking Dr. Rollcutter's finite elements class, getting good with the 3D plot is so important, because that is like, he makes you do all of the MATLAB like finite elements plotting yourself, and so that is so helpful for making sure you can visualize things well.
That's a good comment. So in that class, you're creating objects or surfaces of objects, and right, Nick? I mean, it's like you've got all these nodes, and they have a geometry to them, so the dimensions are going to be the same, right? And coming up with those 3D plots. I know I use a lot in data, and I know Nick does too, with creating these three-dimensional plots and just understanding, because we collect human movement data, we've got three-dimensional markers. They work really well in Cartesian coordinates, and just making sure it's kind of a gut check. It's like, is my data good? That's what I use plotting for a lot. Okay. All right, and let me say this too, and I'll reemphasize this. I mentioned this in the last screencast. Even when you're sharing things, among your friends, working on a project together, when you make a plot, okay, get into the habit of at least labeling the y-axis and the x-axis. Okay, because whenever I'm looking at plots someone has sent me, the first question I ask, Nick can verify this, is, hey, what's the y-axis? What's the x-axis? Okay, it's just because it's communicating this information, right? And so if you've even just put a little bit of information in there, it really helps the person looking at your plot. They don't have to assume as much. Okay, it's just really, really, really helpful. Okay. And then the other things like grid on, I mean, that's just my preference. I mean, it just helps me, I think, just because I'm old. So, all right. Well, y'all have a good afternoon. I think someone has office hours right after this. Is that right? Okay, I'm wrong about that. Attend office hours. Okay. We got the WPA on Wednesday. That will include, so the emphasis is on functions, okay, and some of these basic plotting and annotation. All right. Okay. Thanks a lot, guys.
Thank you.
Yeah, my office hours are at 1. So if you guys need office hours today.
And mine are tomorrow before the WPA. So
Okay, cool. And I've got them at 1 p.m. tomorrow as well.
nice.
Professor Davidson,
Okay.
what'd you say was the name of the documentation to get special characters?
You know what? I found that online by typing in, I think I typed in MATLAB Tech, TEX, and it looks like this is underneath Greek letters and special characters in chart text. I'll tell you what, I'll take this and I'll post this link in the Canvas page so that
Okay.
we can always reference it. Or I'll put it in the cheat sheet too. I'll
Okay,
set it up.
thank you.
Okay. Thanks a lot, guys. Nick?